Hello, everyone. Welcome. So in this next lesson of Unit 4, we're going to be using our knowledge of algebraic equations to transform quadratic functions into a specified or a specific form, right? So what we did the last time we were together, today or yesterday or whenever it was we looked at the three different forms of a quadratic, right? And we really pulled on a lot of your background knowledge because you have it. Like you've learned this stuff before to really analyze like what are the benefits of each one. And so now we want to tie that in. Now that we know the three forms, which I'll review momentarily, we want to tie that in with how do you actually use the algebra, like the factoring, the completing the square, the expanding, in order to put it in a specific form, right? So I'm going to go through some examples right now. So let's start by going through the forms. So the forms that we had was standard form, which if I can locate my pen. Oh my goodness, my slate's not plugged in. I'm over here trying to understand what's going on. All right, I think we're back up and running. Oh, there we go. Perfect. Standard form, which is y equals ax squared plus bx plus c, right? And one of the things that this does really nicely for us is that if you plug in 0 for x, the point 0c is your y-intercept, right? So this really nicely gets us our y-intercept. This can also get us our vertex, right? So negative b over 2a is going to be the x-coordinate of the vertex, and then you plug in to find y. To find y. Right? And so you can think about this almost as like part of the way to complete the square, right? It's part of that process, right? If you're going to go ahead and actually complete the square, you would have to take the middle value and factor out a, or divide it by a, right? And then you would be completing the square, right? You would have x squared plus b over ax plus c over a. And then you'd have to figure out, okay, so like what number do I need to add here to make this a perfect square? What we figured out was you actually have to take this value and cut it in half and then square it, right? So, I'd have to take this number, b over a, cut it in half, times 1/2, and that would give me b over 2a, and then square it. So I'd really end up with like b squared over 4a squared in that last spot. But when I went to go factor this, I would just have x plus b over 2a squared, right, plus whatever, right? So this, and oh my goodness, that gives me essentially vertex form. So this is the opposite, right? That tells me that, I'm going to go left b over 2a, and so that's where that negative b over 2a is coming from. This is also, you can think about it as part of like the quadratic formula, right? Other than the square root of the discriminant. Isn't that the quadratic formula? So let's see. So it tells me this, it tells me this. I can use the quadratic formula to find x-intercepts, right? I can use the discriminant to determine types or number of x-intercepts. That's the stuff that I can do when I have this. I can just plug in any value. But it is really nice that it gives us the y-intercept right here. Okay? Oh, perfect. I left enough room. The next one that I have up here is vertex, or sometimes this is called graphing form, right? This is the one that we want to use for graphing. Notice A in all of these is actually the same, right? This A and this A. If A is negative, my parabola is going to open down. It's going to make it reflect over the x-axis, right? If there's that negative value in front. It just got extremely sunny. You guys can't see it. It got really sunny. So this one, just like it says in its name, it gives me the vertex, right? My vertex is going to be HK. Amazing, right? Like super quickly, it gives me that vertex. If I want to find the y-intercept, that's fine. I just need to be careful that it's not in standard form. It's not just k. I need to plug in 0 to actually figure it out, right? So you got to be careful with that. This is also a pretty nice one. Like if I want to find the y-intercept, I would plug in 0. If I want to find the x-intercepts, I would plug in 0 for y, right? And that's something that we actually did. We solved by completing the square. This is like square completed. Go ahead and solve it, right? I would subtract x, divide by a, take the square root, and remember that when I'm taking the square root, it's plus and minus, and then add h. It is also, and I guess this one does as well, it tells me the line of symmetry, right? Oh, that's just going to be x equals h. Right? This one, the line of symmetry or the axis of symmetry would just be x equals negative b over 2a. Right? I mean, I could convert from standard to vertex by completing the square. I have that algebraic knowledge. I could also find the vertex. Right? If I can calculate the vertex and I know what my a value is, I can just write it in this form. If I find, like, this is h. When I plug that back in to find y, that is k. Right? So there's a lot of different ways you can go about this. And then we have factored form, right? And factored form tells us our zeros or our x-intercepts, right? And so those would be at r sub 1, that root is another word for this, the roots, and r sub 2, 0. This actually gets us our vertex pretty nicely too. I'm able to figure out halfway between the roots, right? So I've got the x-intercepts to find halfway between them and then plug in to get y. Again, this a value is the same. And then maybe you can imagine how we can switch between these, right? If I'm going to go from here to here, I probably have to expand, then factor. If I don't have real rational solutions or real rational roots, I'm probably not going to write it in factored form, right? That one's probably the least useful to me. All right. So let's do some examples. So in example 1 here, given y equals 3x squared minus 6x minus 2, find the vertex from standard form. Hence, write down the equation of the line of symmetry. So it says find the vertex from standard form. So this just wants me to directly find the vertex. So I want to remember that to find the x-coordinate of the vertex, I should be doing negative b over 2a. I don't need to do the entire process of completing the square. That's not what this is asking me to do. That's not a good use of my time. When it says hence, that means using what I did to find the vertex, all I need to do is write down, so there's no work involved here. Yay, that's something that's so exciting to us. So negative b over 2a, that's 6 over 2 times 3. So I've got 6 over 6, so the x-coordinate of my vertex is 1. Okay, so I then need to plug it back in, and notice I'm showing my work. I'm showing the plug-in. I'm finding it. I'm not just doing it. Like, this is non-calculator. We haven't used calculators. In fact, we're really barely going to use calculators. I'm going to show you how to do it in some videos, but you're on an assessment, you're not going to be using one. Negative 3 minus 2, so you got negative 5. So that means that my vertex from standard form is 1, negative 5. Hence, write down the equation of the line of symmetry. Line of symmetry, x equals 1. It's an equation. It didn't ask me for this, but what if, like, now it told me, hence, write equation in vertex form. Not by completing the square, right? That could be a question. It could ask you to do it by completing the square. I would then say, okay, so y equals, My a value was 3, x minus 1 squared minus 5. Look how easy that was. I did the work up here. So notice it said hence, so I had to use what I did up here. You need to be mindful that you still need to know the algebra for completing the square. Like that still is, and I'm going to go through that as well. Right, so I can see what's happening here. Oh, my vertex is 1, -5. This is going to open up, right? Oh, hey, what about the transformations from the parent function? The parent function is y equals x squared, parent, and now I'm going off of the transformations. Okay, so there's 3. This is going to go right 1. This is going to go down 5. And that 3 in front is going to make it, you can think of it like a dilation. It's a vertical stretch by a factor of 3. Right? Oh, we did stuff like this for lines and absolute value functions. Remember that? Right, so vertical stretch by a factor of 3, meaning it's going to increase quicker. It's going to get, oh, I have the pen upside down. That was silly. It's going to get narrower is really what this vertical stretch by a factor of 3 is going to do. It's going to increase quicker. Okay, so this is asking it a little bit different. Now this says complete the square to write it in vertex form, hence write down the vertex. So I'm going to do this a little bit differently. So I've got y equals 3x squared minus 6x minus 2. It's the same equation, but we're going to do it by completing the square. So if you would like to move this 2 to the other side, you can. I'm going to choose not to. And notice what's going to be different about this is I'm actually not going to divide by 3. Right, when we were solving, we divided by 3, but now we're not. We're just rearranging. So if I divide by 3, it doesn't disappear. Then I'm going to have y over 3. I guess you could do that and then multiply through by it at the end, but I don't know that I feel that that's necessary. So what I'm going to actually do is I'm just going to factor out the 3 from these 2 right here. I'm going to put this aside. So I've got 3x squared minus 2x. I'm going to have to complete the square there, and then minus 2. Okay, so what's going to make this factorable? Oh, well, it needs to be a perfect square. So x squared, I can't find the pen, it's right there. Okay. This is going to have to be, well, let's think about a nice picture here. X and x, that 2, so this is going to have to be a -1, and this is going to have to be a -1. -1, -1. So what does this little box in here have to be? Oh, it's a -1 by -1. That has to be a 1. Got it. So I've got to add 1. Oh, shoot, I just changed the equation. Well, no big deal. I can just subtract 1. Right? Like, that's keeping it even. That's me just adding 0. Right? So I could go ahead and add the 2 to the other side and then just add 1 over there if I want to stay consistent with what I maybe did when I was solving. But I don't know that I want to do that. Oh, wait, did I do that correctly? Where's my error? I didn't do that correct. I didn't really add 1. What did I do? I really added 3. So I have to, oh goodness, subtract 3, sorry. Right, so I had to remember that this number here, like think about what I did here. Go back to the original one. I had already divided it out and factored out that 3. So I've got to factor it back in. So I'm really subtracting 3. Okay. So y equals 3, factor this, x minus 1 squared minus 5. Oh, bam, I've got it. If you're getting confused with all of this, maybe here's another way you could do it. Maybe I will divide everything by 3, and I'll move that 2 over. Y plus 2 over 3, I'll just go with that, equals x squared minus 2x. Okay, so then let's complete the square. I'm just trying to give you another way you could think through it. Same idea, I'm going to have to add 1, so I'll have to add 1 over here. Right, so this will give me y plus 2 over 3 plus 1 equals, factor this, x minus 1 squared. Okay, let's get this taken care of. I'll go ahead and I don't know, I'll multiply both sides by 3. That's going to get rid of that 3. Y plus 2 plus 1 equals, oh no, plus 3 plus 3 times x minus 1 squared. And then that's y plus 5 equals, hey, yeah, that's another way if you want to think about it like that. And it gets to be the same thing. And then I can, therefore, I've done it by completing the square. These are both completing the square. Hence, write down the vertex. Make sure you finish the problem. So vertex is 1, negative 5. Right? Let's keep going. So find the x-intercepts using the method indicated. So this says convert to vertex form and then find the x-intercepts. Okay, so it doesn't want me to factor. It wants me to convert it to vertex form. It doesn't say if I have to complete the square or not. Right? So I could use either method. I could use negative b over 2a. Right? So I could find the x-coordinate of the vertex is negative b over 2a is negative 2 over negative 3 times 2, right? 2a. Sorry, I just flipped that the other way. So that's negative 2 over negative 6. That's 1/3. And then I could go ahead and plug it back in. So negative 3 times 1/3 squared plus 2 times 1/3. I don't love working with fractions, but it's fine. Negative 3 times 1/9 plus 2/3 plus 5. That's going to give me negative 1/3 plus 2/3 plus 5. Negative 1/3 plus 2/3 is 1/3 plus 15/3. So I've got 16/3 there. Right? And so now, okay, so I've now got, I don't know why, I'm going to erase that line and I'll come back to it. So that tells me then I've got, this is y sub b. Y equals negative 3 x minus 1/3 squared plus 16/3. Right? So, oh, I've converted it to vertex form. Now I'm going to go ahead and actually find the x-intercept. So I'll set this equal to 0. And then minus 16/3. Divide by negative 3 or multiply by negative 1/3. Right, that's going to make this go away. So that's 16 over 9 equals x minus 1/3 squared. When I go ahead and I take the square root, that's going to give me plus or minus 4/3 equals x minus 1/3. And then I can do, it's going to be 1/3 plus or minus 4/3, which mathematically I should do that. So my two x-intercepts are 5/3 and negative 3/3, which is negative 1. So it's going to be 5/3 0 and negative 1 0 would be my x-intercepts. Right? So I didn't even do completing the square. I could have also done completing the square, right? And I'm going to squeeze it up here. Sorry about that. Oof. Right. So let's see. Y equals, I'll go ahead and do what I did in the second round there. I'll subtract 5 and divide by negative 3. So I'm factoring it out right away. And then that's going to give me, this would be x squared minus 2/3 x. And I know I'm going to have to add something to both sides. Right? So, okay, so let's see. I'm going to have to take that negative 2/3 and split it up in half. Right? So it'll give me negative 1/3. Square it, and I've got 1/9. So I'm going to be adding 1/9 to both sides. So I've got y minus 5 over negative 3 plus 1/9. I'm not even going to worry about that. I'll deal with that in a moment. X minus 1/3 squared. Okay, so I'm going to now go ahead and multiply through by negative 3. So this is me completing the square, which you probably want to know both ways. So that's going to make this cancel, but then I also have to make sure I'm multiplying it to both parts. And I have to do it over here. So I've got y minus 5 minus 1/3, right? Negative 3 times 1/9 equals to negative 3 times x minus 1/3 squared. And let's deal with this. So this is actually negative 15/3. So that's that 16/3. So y minus 16/3 equals negative 3x minus 1/3 squared. And then I can add the 16/3. Right? Notice I have no decimals. I've not rounded anything. I haven't picked up a calculator. None of this is calculator based. You're not going to be assessed using a calculator at all. Right? So then I got the same thing, and then my process of finding the zeros would be the same. Okay? So this next part of example 3, we're going to be using the quadratic formula to find the x-intercept. So even though, yes, I can certainly plug in 0 and do it this way, I'm asked to use the quadratic formula. And in order to use the quadratic formula, I need it to be in standard form. So I'm going to go ahead and convert this to standard form. So that means I need to expand it. So I'm going to start with this right here, x minus 4 squared. Well, that's x squared, double distribution. If you need to write it down on the side for yourself to picture, that's fine. Right? X squared minus 4x, so minus 8x plus 16. It's perfect square. Plus 6. Distribute 2x squared minus 16x plus 32 plus 6 is 38. Okay, great. So now I've got standard form. And then I'm going to use the quadratic formula to find the x-intercepts. So in order to do that, I'm gonna actually find the discriminant first, right? So that's b squared, negative 16 squared, minus 4 times a times c. I could probably factor out 2, can't I? I'll do that. Why don't I do that? I'll factor out a 2 and then do the quadratic formula. Changed my mind. Smaller numbers. So what was it? Now I've got b squared, negative 8 squared. It's not, it's in parentheses. Minus 4 times a times c. Smaller numbers, we like that. 8 squared is 64. Minus 4 times 17 is, what is that? 48? No. 58, right? Yeah, 58. 64 minus 58 is 6. Okay, so I'm gonna have two real irrational solutions. Two real irrational solutions or x-intercepts. Okay, so then I can actually finish this. So the opposite of b plus or minus the square root of b squared. Oh no, I already did that. 6 all over 2a. All that happened here is when I factored out that 2, that dilation factor, it's gonna make it so I don't have to simplify as much now, right? I don't have anything I need to simplify this by, whereas had I not factored it out, I mean, I would have been dealing with bigger numbers that are harder to work with in my head, but I would have had to simplify more. So now I don't think there's anything, I mean, I guess I could do this. I could say 4 plus or minus root 6 over 2. Right, but I've got my two x-intercepts. I've got 4 plus root 6 over 2, 0, and I've got 4 minus root 6 over 2, 0. Just make sure you're reading directions and you're practicing. I think this is mine. No, I've got 2 more examples. Oof, right. Write the following quadratic equations in standard form. Okay, right, some more practice with it. Even though I've lost the pen. So again, so y equals 2. If you need to write this out separately to picture it, great. X squared minus 14x plus 49 minus 9. So y equals 2x squared minus 28x plus 98 minus 9. 98 minus 10 would be 88, so 89. Right, so, oh, there we go. Standard form. Oh, what would your y-intercept be? Oh, 0.89. Look how nice that is. Fabulous. You can even see what would have happened if I plugged in 0 here. I would have gotten negative 7 squared, which is 49. 49 times 2 is 98. Oh, 98 minus 9. Oh, check that out. 89. Right? Okay. Same thing here. We're going to multiply this out. So y equals, I'll deal with that 2 at the end. Because the 2, if you want to deal with it at the beginning, it only factors into one of them. I'm not going to like multiply it out to all 4 parts. So just be mindful of that. 2x squared minus 5x plus 8 minus 5 plus 8 is 3. And then minus 20. So that's going to give me y equals 4x squared. Oh, plus 6x. I lost my train of thought there for a minute. Minus 40. And that's standard form. So my y-intercept there would be 0, negative 40. And it opens up, so I know I'm going to have 2 x-intercepts. Oh, wait, but I knew that right away. Right? I knew that my x-intercepts were negative 4 and 5 halves. So check this out. I'm sorry. I don't know why I wrote it like that. Negative 4, 0, and 5 halves 0. If I wanted to find the vertex, I could average these two. Algebra, the arithmetic mean. So negative 4 plus 5 halves, negative 8, what is that, 3 halves? Negative 3 halves. Divided by 2, so that's times 1/2. I get negative 3/4. That's actually going to be the x-coordinate of the vertex. I can even do it from here. Watch this. The opposite of b over 2a, I get negative 6 over 8, which is negative 3/4. And then I can plug it back in, right? Pretty cool. There's a lot of different ways, like look for connections. All right, so I believe I've got one more. I'm running out of time, so I hope so. Write the following quadratic equation in vertex form and then describe the transformations, which I talked a little bit about earlier. So the first thing I want to do is write it in vertex form. It doesn't tell me how I need to do that. So I'm going to do what I just did. I'm going to take my 2 x-intercepts, 3 and negative 2/3, and I'm going to average them. Right, so this I can rewrite as 9/3 to help me. So that's negative 7/3 divided by 2 is like times 1/2. So that will give me negative 7 over 6 is the x-coordinate of the vertex. I'll go ahead and just plug that right back in to find the y-coordinate of the vertex. So that's negative 7/3 minus 3. And then 3 times, oh no, it's negative 7/6. Come on, Miss Gallen. Times negative 7/6 plus 2. Okay, so negative. This is the same thing as, what is that, 18/6? Negative 7 minus 18, what's that? Negative 7 minus 18 isn't that negative 25? I think so, yeah. Negative 25 over 6. I'm sure you guys will share with me if I'm in there. It happens. And then this will go away, and this is a 2, and so then that's 4 halves. So negative 7 plus 4. What's negative 7 plus 4? 7 plus 4. It's negative 3 halves. So I know I'm going to end up with a negative here. Right, that'll be negative. This actually simplifies. I'll go ahead and do this. This is a 1, and this is a 2. So then I end up with negative out in front, 25 over 4. So I've got negative 25/4. Hopefully I'm doing this right. So vertex form would be y equals, that negative is still up front, the negative 1 is still my a value, x plus 7/6 squared minus 25/4. If you wanted to put this in standard form and then complete the square, that's totally fine. Just make sure you're checking my algebra. It's possible that I'm doing it in my head and I don't have it pre-done. So if I made a mistake, good on you. You caught a mistake. And so then describe the transformation. So this is going to go left 7/6, down 25/4. And then this is that negative in front is going to make it reflect over the x-axis. It's going to make it flip down. That's what's going to make it open down. Oh no, so I must have made an error somewhere. It can't have two x-intercepts. Oh man, negative 7/6. Let's see if I can find my own error. 3 and negative 2/3, I averaged them, and that was 9. So negative 7/3, negative 7/6. I think this is fine. So it must have been in my plugging it back in. Negative 7/6 minus 18/6, and then times negative 7/2 plus 2. Negative, is this not negative? Is that where my error is? Oh my goodness. 9 minus 2 is positive. Oh my goodness. Oh my goodness. 7 minus 18. What's 7 minus 18? Not 7, negative 7. So that's negative 11/6. I'll fix my error right here. That's negative 11/6. And then this is 7 plus 4, which is 11 halves. Okay, so then that's going to give me a positive 121 over 6 times 2 is 12. I believe that's right now. So this should be 121 over 12. So then this would be up 121 over 12, right? So see how, like, I looked back at it and I was like, wait, that doesn't make sense. You can't have two x-intercepts if your vertex is below the x-axis and then opens down. Okay, so hopefully that math is right now. And then let's go ahead and do this last one. And so this one right here, I've got about 3 minutes. I am going to go ahead and, you know what, I'll do completing the square. So I'm going to subtract 1 and divide by negative 2. And then that's going to give me x squared plus 5 halves x. And I'm going to be adding, 5 halves x, adding something to complete the square. So we'll take that middle term and divide it in half. All right, split it up over those two sides of the square. And that will give me 5/4, and then we'll square it, which will give me 25 over 16. So 25 over 16. So I'll do 25 over 16 over here as well. So I've now got y minus 1 over negative 2 plus 25 over 16 equals x plus 5/4 squared. I'm going to multiply everything, both sides, by negative 2. And that will make sure you distribute that. So that will give me y minus 1 minus, right? So that's 25 over 8 equals to negative 2x plus 5/4 squared. This is the same thing as 8 over 8. So negative 8 minus 25 gives me negative 33. So that will give me y minus 33 over 8 equals negative 2x plus 5/4 squared. And then I can go ahead and finalize this. Sorry, I'm writing on a weird angle. With plus 33/4. Right? And so what this does is, there's a lot that's going on here. So this is going to go left 5/4 and up 33/4, eighths, 33/8. And then it's going to reflect over the x-axis. That's what that negative does. And then it's going to become, it's a vertical stretch by a factor of 2. So it's going to become narrower is what that's going to do, but it's officially called a vertical stretch by a factor of 2. Alrighty, so that is where I'm going to leave you guys. So what we really did in this lesson was kind of tie in what you've done with the algebra pieces, where we were really focused more on solving and really just looking at re-expressing and figuring out what different characteristics I could find. When we come back together next, we're going to be looking at, what is it called? How this actually applies to graphing and actually identifying the characteristics. And again, like there's no calculator that has been used. So I really, really would encourage you to practice it that way so that you're not caught in an interesting place. So make sure that you go ahead and complete your homework, which is the scavenger hunt. You're uploading your work for each picture, and you're going to actually be rearranging the slides. So the slide should be, you're starting with slide 1, but you're going to be rearranging them. So slide 2 that's currently there won't be necessarily slide 2 that you end with. So like wherever the next problem is that has the answer to slide 1 on it, you're going to be dragging to that point and then doing that problem next. So with that being said, thanks everyone for sticking with me, and we will see you all soon.